The overall goal of this procedure is to synthesize multinuclear platinum anticancer complexes based on the structural characteristics of the drugs picoplatin and BBR-3464. This is accomplished by first synthesizing bispyridine bridging ligands through the conjugation of isonicotinic acid and a diaminoalkane using an amide coupling reaction. The second step is to recrystallize the ligand from hot water. Next, the ligand is coordinated to platinum by reaction with transdiamine dichloroplatinium 2. The final step is purification of the metal complexes by fractional precipitation from water using acetone. Ultimately, successive amide coupling and platinum coordination is observed most definitely using proton nuclear magnetic resonance spectroscopy.
The application of this technique is in the design and synthesis of new anti-cancer drugs. We've done this through the combination of particular characteristics of different platinum agents.
Generally, individuals new to this research area will struggle with the chemical characterization, particularly how the ligand peaks in the proton NMR change chemical shift and shape upon platinum coordination.
First, dry a 3-neck round-bottom flask in an oven at 100 degrees Celsius for 1 hour to ensure that all moisture is removed. Once the flask has cooled to room temperature, add 0.5 moles of solid isonicotinic acid, in this case 1,10-diaminoalkane, along with a magnetic stirring bar. Cap the necks of the flask with rubber septa and replace the air in the flask with nitrogen through the use of a nitrogen-filled balloon.